Hello friends, today we will do the derivation of electric field due to uniformly charged sphere. This is another application of the Gauss law. So let us start the derivation. Now consider a charge plus q. Consider a charge plus q be uniformly distributed in a sphere of radius r. Suppose we have a sphere having radius r and plus q charge is uniformly distributed with center at O. Now here the charge density, that is the volume charge density, is rho at every point and it is uniform. So what is rho? Rho is the volume charge density. This is basically charge per unit volume. Okay, so suppose here is a point P at a distance small r from the center of the charge distribution. Suppose here is a point P at a distance small r from the center O. Okay, so three cases arises here. First we will do the first case. The first case is we will calculate the electric field intensity at an external point that is r greater than r. So let point P lies outside the charge sphere as shown in this figure. In order to find the intensity of electric field at point P, we will draw a concentric Gaussian spherical surface of radius small r through this point P. Okay, so I will try to draw this concentric Gaussian surface of radius r. All the points on this surface are at the same distance from the center, that is at r, small r. Due to spherically symmetric charge distribution, the magnitude of intensity of electric field at all points on this Gaussian surface is same. We will calculate, if we will calculate the electric field here or here or here at every point, maybe here, the intensity of electric field will be same. So suppose at this point P we will take a area element ds, and as I have told in my previous lectures that the direction of the area element is always outward, and due to the positive charge the direction of the electric field is also outward, okay, along this direction. Fine. So from this area element, flux, small amount of flux will be d phi equals to E dot ds. So dot product is there, EDS cos theta. What is the direction between E and ds? It is 0 degree. EDS cos of 0, as both are in the same direction, as cos 0 is 1. So it will be d phi equals to EDS. Therefore, the flux through whole of the Gaussian sphere will be phi equals to closed integral of E ds, or this will be E integral of ds. So what should be integral of ds? Integral of ds is 4 pi r square, that is the area of the sphere. Okay, so flux will be equals to E 4 pi r square. So this is our equation number 1. Now from Gauss law, from the statement of Gauss law, the flux is equals to q by epsilon naught. Okay, This is the statement of Gauss law. I have already discussed it. Now by comparing equation 1 and equation number 2, E 4 pi r square equals to q by epsilon naught, or E equals to q upon 4 pi epsilon naught r square, q upon 4 pi epsilon naught r square. This is the electric field intensity due to the charge q, and but at a distance r from the at a distance r at an external point from the sphere. Okay, this result is just same as the electric field intensity due to point charge, where we have derived the Coulomb's law from the Gauss law. Okay, this is the just same result. So second point is at point on the surface of sphere, that is when small r is equals to capital R. Okay, small r is equals to capital R. If the point P is situated at the surface of uniformly charged sphere, okay, so point P is this is center O. Point P is situated here, and then this capital R is equal to small r. Then electric field intensity will be just equals to 1 by 4 pi epsilon naught q upon r square. Just you have to replace the small r in the first case with the capital R. Okay, so this is the electric field intensity. The third case, the important case, if there is a point at an internal point, that is r is now less than capital R. Okay, that is there is a point that is internal to the radius r. Now in order to determine the intensity of electric field at point P inside the charge sphere distant r from the center O, so this was our O point plus q charge was placed here at a distance r. Now but suppose there is point inside this radius r, and this radius small r is lesser than r, and this will be our small r distance. Okay, now point P is here now. Okay, therefore the electric flux through this point will be phi equals to integral of E dot ds integral of EDS equals to E 4 pi r square, equation number 5, because EDS both are in the same direction, and it will be cos 0 degree, and then it will become EDS, cos of 0 degree EDS. Now let us now calculate the total charge contained inside the Gaussian surface. Now as the charge is uniformly distributed throughout the uniformly charged sphere, the charge is uniformly distributed inside the charged sphere. Now here comes the concept of volume charge density, rho, that is the total charge divided by the total volume. Now total charge is plus q, total volume is 4 by 3 pi capital R cube, because we are talking about the total charge distribution inside the sphere. Now then we will discuss about the volume occupied by the Gaussian sphere. The volume occupied by the Gaussian sphere. Okay, so it will be equals to 4 by 3 pi. Now what is the radius of the Gaussian sphere? This is small r. This is 4 by 3 pi r cube. Therefore the total charge contained by the Gaussian sphere, total charge contained by the Gaussian sphere. Okay, this sphere I am talking about this portion only now. Now suppose the total charge contained in this sphere is Q1. So this will be equals to volume charge density rho multiplied by the volume Q, because rho equals to charge by volume, then Q1 equals to volume charge density multiplied by the volume. So suppose this is our equation number 6, and this is our equation number 7. If we will put the value of equation 6, that is the rho value, and equation 7, that is the volume result here, then Q1 equals to Q upon 4 by 3 pi capital R cube. And what was the volume? 4 by 3 pi r cube, by putting the equation 6 and 7. So 4 by 3 pi, 4 by 3 pi cancels out. So what you will get? You will get Q1 Q r cube by capital R cube. This is equation number 8. Now according to Gauss law, flux is equals to integral of E dot ds equals to Q1 by epsilon naught. Equation number 9. Now equation number 9. Now comparing equation 5 and equation number 9. Comparing equation 5. What was equation number 5? This was the equation number 5. Okay, 5 is equals to E 4 pi r square. Equation number 9 is this one, Q1 by 4 pi epsilon naught. So it will be E 4 pi r square equals to Q1 by epsilon naught. Now put the value of Q1. From equation number 8 in this equation. So this is equation number 10. In equation number 10, put equation 8 in equation number 10. So you will get E 4 pi r square 1 by epsilon naught Q r cube by r cube. So r square cancel out. So we will get E q r by 4 pi epsilon naught r cube here. So what is the conclusion? That is the intensity of electric field due to uniformly charged non-conducting sphere at an internal point P is directly proportional to the distance of the point from the center. Okay, so what we have discussed here, we have discussed the external point and calculated the external point intensity of electric field is equals to Q by 4 pi epsilon naught r square. Then at the sphere, at the point at the surface, just replace small r with a capital R. Internal point. Okay, internal point. Here in this case, we will discuss the concept of the volume charge density, and by using the volume charge density, we have calculated calculated the intensity of electric field inside the sphere by drawing a Gaussian sphere QR. Result is Q small r divided by 4 pi epsilon naught r cube. I hope so you have understood the derivation. Thank you. Thanks a lot.